Today, we're diving into a really cool breakthrough in how AI learns to connect what it sees with what it says. We're talking about a new model that figured out how to work smarter, not harder, and the results are pretty amazing.
So, let's kick things off with a little test. We show an AI this picture of a house, and we ask it a super simple, open-ended question. Is this photo unusual?
And wow, check this out. The AI doesn't just see a building, it totally gets the context and nails why it's weird. It understands that, houses aren't supposed to be built like that. So where does this common sense come from? It's from a new model called BLIP-2, and its whole approach to learning is a real game changer. Okay, so let's get into how it works. First, let's just back up a little bit. What are we even talking about when we say an AI can connect vision and language? Well, it's one thing to just describe an image, but it's another thing entirely to really understand it. For example, you can show an AI this photo and ask for something creative, like write a conversation. And look, it doesn't just spit out, a cat is on a dog. It makes up a little story that's actually plausible, kind of charming even. That's the magic of something called vision language pre-training. But getting an AI to this point has been a huge, huge challenge. Which brings us to the big problem this was all designed to solve: the absolutely insane cost of building AI models that are this powerful. For a long time, the only way to get more powerful AI was just go bigger. It kicked off this crazy AI arms race, with companies throwing fortunes at building and training these absolutely gigantic models from the ground up.
So you've got two ways to go about this. The old way, this end-to-end training, is like trying to teach one person to be the world's best artist, poet, and scientist all at once. It's just insanely expensive and not very flexible. BLIP-2, well, it takes a totally different route. It's a modular approach that literally builds on the shoulders of giants.
So how does BLIP-2 pull this off? Well, just think of it like building a super team, kind of like the Avengers for AI, where every member is already a master of their craft.
First up, you bring in your art historian. This is a pre-trained image encoder, an AI that's already an expert at seeing and understanding images. And the key here is that it's frozen. We're not retraining it, which saves a ton of time and money. We're just borrowing its expertise. Next, you recruit an eloquent poet. This is one of those huge, large language models. The brains behind chatbots. It's a master of language, and just like the art historian, it's also frozen. We're not touching its core knowledge. Okay, so here's the million-dollar question. You've got your vision expert and your language pro, but they speak totally different languages. One thinks in images, the other in words. How on earth do you get them to talk to each other without starting from scratch and spending a fortune? The answer, you hire a translator, a super smart, super efficient translator. And in BLIP-2, that's this little piece of magic called the querying transformer or Q-former. Its only job is to bridge the gap between sight and sound. So here's how this dream team actually works together. And it's so clever. The art historian sees the image. Then our translator, the Q-former, jumps in. It doesn't just grab everything. It asks smart questions to pull out only the most important bits. Then it hands that perfect little summary over to the poet, who then writes the final text. It's beautiful. So this whole system really hangs on that translator, right? The Q-former. So how do you train it to be so good? Well, it happens in two really clever steps.
Step 1 is all about learning to see the right things. The Q-former learns to find the visual stuff in an image that's actually relevant to the text. Then, Step 2 is all about learning to talk the right way. It learns how to package up that visual info into the perfect prompt that the big language model can just instantly understand.
And if you're wondering, does that first stage really matter? Oh yeah. Just look at this. This chart tells the whole story. With that first stage of training, performance is great. Take it away, the model basically falls apart. That step is absolutely the secret sauce here.
Okay, so the result of all this smart training isn't just a cheaper model. It's a model that's just ridiculously good. Let's see what it can actually do. I mean, check this out. It can act like a product expert. You just show it a photo of a car, ask about its advantages, and boom, it gives you a detailed breakdown just from looking at the picture. Or how about this? It can be your personal chef. You show it this awesome cat-shaped pizza, and it just tells you the ingredients you need to make it. It actually understands what it's looking at. But here is the real knockout punch. This table puts BLIP-2 head-to-head with Flamingo, a gigantic model from DeepMind. And just look at these numbers. BLIP2 actually beats Flamingo on a key test while using, get this, 54 times fewer trainable parts. That's not just better, it's a completely different league of efficiency.
So what does this all mean? It means you're getting better performance for a tiny, tiny fraction of the cost. This isn't just an improvement, it's a total shift in how we can build powerful AI, making it way more accessible for everyone.
Which leaves us with this final thought. For so long, we thought bigger was the only way to get better AI. BLIP2 just proved that wrong. So, if working smarter is already beating brute force, what's coming next? What else can we unlock with this philosophy?